Over millennia, gravity worked its magic. The cloud contracted, pulling material inwards. At its heart, a star began to form, our sun. As the sun ignited, it bathed the swirling disk of dust and gas in light and heat. This material, the leftovers from the sun's formation, continued to spin and clump together. Solar, nebula, scientist. These clumps, drawn together by gravity, grew larger and larger. Eventually they formed the planets we know today. Earth, our home, coalesced from this cosmic dust. A young planet, still finding its way in the vastness of space. This fiery birth set the stage for an incredible journey, a journey of transformation, life and evolution. But even in this chaos, a kind of order was emerging. Heavy elements, like iron and nickel, sank towards the center of the Earth. This formed the planet's core, a dense sphere of molten metal. Lighter elements, like silicon and oxygen, rose to the surface. This formed the mantle, a layer of molten rock that surrounds the core. Early Earth geologists. As Earth continued to cool, the outermost layer of the mantle solidified. This formed the Earth's crust, the solid ground beneath our feet. This process, called differentiation, created the layered structure of Earth that we know today. Debris from the collision was ejected into space, forming a ring of molten rock around the Earth. Over time, gravity pulled this debris together, coalescing into a single celestial body, our Moon. The Moon's formation had a profound impact on Earth. Early Earth geologists. Its gravitational pull stabilized Earth's rotation, preventing wild wobbles that would have made life impossible. The Moon also created tides, which played a crucial role in the development of life.
Section 4. The Hadean Eon, a hellish cradle of life. The Hadean Eon, named after the Greek underworld Hades, was a time of intense heat and volcanic activity. The Earth's surface was a molten wasteland, constantly bombarded by asteroids and comets. The atmosphere was thick with toxic gases, and there was no liquid water to be found. It was a truly hellish environment. But even in this inhospitable world, the seeds of life were being sown. The building blocks of life, such as amino acids, may have formed in the primordial soup of early Earth's oceans. These molecules, self-replicating and evolving, would eventually give rise to the first life forms.
Section 5. The Archean Eon. Life finds a foothold. As Earth cooled, the Hadean Eon gave way to the Archean Eon. The bombardment of asteroids and comets decreased, and the Earth's crust began to stabilize. Oceans formed as water vapor condensed from the atmosphere. This was a time of great change and promise. In these early oceans, life emerged. The first life forms were simple, single-celled organisms called prokaryotes. These microscopic pioneers thrived in the harsh conditions of the early Earth. They were able to survive without oxygen, and they used energy from the sun or from chemicals to grow and reproduce.
Section 6. The Proterozoic Eon, Oxygen, and the Rise of Complex Life. The Proterozoic Eon was a time of dramatic change for Earth. One of the most significant events was the Great Oxidation Event. Cyanobacteria, a type of bacteria that could perform photosynthesis, released oxygen into the atmosphere. This oxygen, initially toxic to many life forms, eventually transformed the planet. The rise of oxygen paved the way for the evolution of more complex life forms. Eukaryotic cells, which have a nucleus and other organelles, emerged during this time. Eukaryotes would eventually give rise to all plants and animals. The continents also began to take shape during the Proterozoic. Supercontinents, such as Rodinia and Pannotia, formed and broke apart. These massive land masses influenced ocean currents and climate, further shaping the evolution of life on Earth.